On this question, I have the function f of x equals x squared times square root of 1 minus x squared. I want to calculate the derivative. Before I calculate the derivative, I am going to rewrite the radical in a different format so that it's a little easier to calculate the derivative. I'm going to write this as x squared times 1 minus x squared to the 1/2 power. That square root is the same as the 1/2 power. So now I'm ready to calculate the derivative, and I'm trying to decide what overall pattern I'm going to use to calculate the derivative. And something that can help you decide what the overall pattern is to think about x being a number and what order of operations you would use to calculate that expression. So if x were a number, I would calculate what x squared is. I would use order of operations, and I would calculate the x squared inside the parentheses and do that subtraction. Then I would apply that radical, the 1/2 power, and the very last thing that I would do would be to do the multiplication. So that very last operation is going to be what indicates to you what pattern, what derivative pattern you should follow. So because my last operation is a product, I'm going to use the product rule to calculate this derivative first. So the product rule, I'm going to calculate the derivative using the product rule, and the product rule is when you are calculating the derivative of a product, u times v. The product rule says you do the first times the derivative of the second plus the second times the derivative of the first. So u times v prime plus v times u prime. Okay, so we're going to follow that pattern of the product rule. And we have the first factor, x squared, times the derivative of the second factor. I'm going to write 1 minus x squared to the 1/2 power, and I need to calculate the derivative of that. So then I'm going to add the second factor, 1 minus x squared to the 1/2 power. The derivative of x squared is 2x. So I still need to do the calculation of this derivative right here. And with this derivative, I need to use the chain rule. So the chain rule is when you have the derivative of a composition of functions, or one function substituted inside of another function. And that's what we have right here in this yellow highlight. 1 minus x squared is on the inside. That's substituted inside of this 1/2 power, which remember is a radical. So 1 minus x squared is your inside function, and 1/2 is your outside function, that 1/2 power. So when we have an inside function and an outside function, this is the pattern that we follow for calculating that derivative. We calculate the derivative on the outside function, we leave the inside function alone, and then we chain by multiplying by the derivative of the inside function. So that's the pattern that we're going to follow. So I'm copying down the x squared. I'm going to copy down the x squared. Copy down that x squared, and now let's calculate the derivative using the chain rule on 1 minus x squared to the 1/2. So we've got our outside function, which I said is 1/2, and we want to calculate the derivative on the outside function first. So with it being a power, we're going to follow the power rule. So the power rule says we do the power becomes the coefficient, then The new power is 1 less than the old power, so it's negative 1/2. And now we want to leave the inside function the same and then chain by taking the derivative of the inside function. So the inside function is 1 minus x squared. We leave that the same. And then we're going to chain by multiplying by the derivative of the inside. Derivative of 1 minus x squared is negative 2x. So then we're copying down the rest, 1 minus x squared to the 1/2 power times 2x. So now we have calculated that derivative, and I didn't need this bracket right here. Okay. So we have the derivative. It's a little bit messy, so let me talk about how we're going to clean this up. So on this example, I'm going to use a different method than I normally use. I usually talk about a factoring method, and this time I'm going to use a slightly different method. So what I'm going to do is notice that I have this negative 1/2 power. I'm going to write that as a fraction because it has a negative exponent. I can also do a little bit of canceling here. This 2 cancels this with this 1/2. So this first term can be written as x cubed over 1 minus x squared to the 1/2. So then I have, on the other one, I have 2x times 1 minus x squared to the 1/2. Okay, now that I have it written in a fraction form, I'm going to try combining these two into a single fraction. So this is my denominator that I have. So I want a common denominator. The second term is over 1. So to get that common denominator, I'm going to multiply by 1 minus x squared to the 1/2, 1 minus x squared to the 1/2. So this is going to give me x cubed over 1 minus x squared to the 1/2. Okay, then the second term, we now have that common denominator, 1 minus x squared to the 1/2. And in the numerator, I've got that 2x, and this factor and this factor have the same base. So when we multiply them, we can add the exponents. So that will be 1 minus x squared, and 1/2 plus 1/2 is 1. So now I have 1 minus x squared to the 1/2 in the denominator. That's my common denominator. And in the numerator, I'll distribute that 2x to both the terms. It's x cubed plus 2x minus 2x cubed. I can combine the like terms in the numerator, and I'll have 2x minus x cubed over the square root of 1 minus x squared. So that gives me my derivative simplified with that algebra. Okay, I wanted to come back here and correct a mistake that I made. I just noticed that I didn't carry this negative right here. So there would be a negative on this x cubed. Let's carry that negative down to right here. And that would make this, instead of a negative 1x cubed, would make it a negative 3x cubed. For this question, we want to find the derivative of the function y equals cube root of 9x squared plus 4. But before I calculate the derivative, I want to rewrite this radical as an exponent, as a power. We'll write this as 9x squared plus 4 to the 1/3 power. I want to write it as a power so I can use the power rule when calculating the derivative. So when I calculate this derivative, what I notice is that I have that power, And inside of that power, I have 9x squared plus 4. So when I have one expression inside of another expression, that's my indication that I want to use the chain rule. And just to be a little bit more like stating it as when I have to use it, the expression on the inside, anytime that's something other than x. So if the inside is something other than x, you want to use the chain rule. So the chain rule derivative, that pattern, we use that pattern anytime we have one function that is substituted inside of another function. So here I have f on the outside and g on the inside. The pattern I'm going to follow is, for the chain rule, is that we calculate the derivative on the outside function, leave the inside function the same as it started, and we're going to chain by multiplying by the derivative of the inside function. So we have on the outside that power. That's our f. So because it's a power, we're going to use the power rule. The power rule is where we take the power and we make it the coefficient. And then our new power is going to be 1 less than our old power. So 1 less than a third. Then our inside function, g of x, is the 9x squared plus 4. We want the inside to stay the same, and then we're going to chain by multiplying by the derivative of the inside. So we want 9x squared plus 4, and we're going to chain by calculating the derivative of that. Derivative of 9x squared is 18x. Derivative of 4 is 0, so we don't need to write that down. So then I need to simplify this. 1/3 minus 1. 1/3 minus 1. That's 1/3 minus, I'm going to need a common denominator, 3 over 3. And 1/3 minus 3 over 3 is negative 2/3. So it's going to give 1/3 times 9x squared plus 4 to the negative 2/3 power times 18x. This is 18x over 3 times the cube root of 9x squared plus 4 squared. And then 3 will divide into 18. 3 divides into 18 6 times, so we can write that as 6x over the cube root of 9x squared plus 4 squared. And maybe I probably would write this as 6x and 9x squared plus 4 and leave that as the 2/3 power instead of turning it back into the radical. Okay, for this question, we want to find the derivative of the exponential function. We have y equals x squared e to the negative 9x. So when we're calculating the derivative, I want to think about what overall rule to use. And I notice that I have a product here, the product of x squared and e to the negative 9x. Both factors, so my factor of x squared has an x in it, and my factor of e to the negative 9x has an x in it. So I need to use the product rule to calculate the derivative. So I'm following that product rule. The product rule is when you have the derivative of a product, u times v, and this is the pattern we follow. U times v prime plus v times u prime. That's the first factor times the derivative of the second factor plus the second factor times the derivative of the first. So I'm going to calculate the derivative. The first factor is x squared times the derivative of e to the negative 9x plus the second factor, e to the negative 9x, plus the derivative of the first factor when I calculate the derivative of x squared. So that's the product rule pattern, and I need to calculate the derivative on these two factors. Now, when we calculate the derivative of e to the negative 9x, I need to use my derivative rule for e to the x, or e to the u. I wrote e to the u. This, when we write e to the u instead of e to the x, the e to the u has the chain rule built into it. So e to the x, the derivative of e to the x is e to the x. But I'm doing e to something other than x. So e to something other than x, the rule looks like this. Derivative of e to the u is e to the u, and I need to chain by multiplying by the derivative of the exponent. Derivative of what's in that exponent, or the inside. So if I'm doing the derivative of e to the negative 9x, that's e to the negative 9x times the derivative of negative 9x, which is negative 9. I need to calculate the derivative of x squared, that's 2x. And to clean this up, I would have negative 9x squared e to the negative 9x plus 2x e to the negative 9x. And this is an acceptable answer, but I don't like to have negatives in the front. So I'll write this as 2x e to the negative 9x minus 9x squared e to the negative 9x. Thank you for checking out my videos. Have a great day.